So we're trying to see what happens to copper chloride, which is CuCl2. Copper's 2+, and then the chloride is 1-, so it's CuCl2. And so just to balance that, inside the reaction, inside the water, you would have that going on. So they would dissociate in this way before any voltage is applied. So we've got which one is going to appear at which electrode. Well, the copper is going to appear at the negative electrode, and the chloride, is going to appear at the positive electrode. The copper appears at the negative electrode because it's less reactive than hydrogen. If it was more reactive than hydrogen, it's the hydrogen that appears. So it's the less reactive of the two that is what appears at that electrode, basically. Now, when we draw the half equations, we only ever use plus. We can't use minus. So so what we do is we do what happens before and what happens after. So what is there before and what there is afterwards. So at the beginning there is chlorine. And then,
right, so you've got.
All right, so if you got the chlorine and the chloride ion going towards the positive electrode, and it's going to collect some, it's going to offload its electrons. So to start off with, you got a chloride ion, and afterwards you got a chlorine molecule. Two chloride ions and then going to a two chloride ions going to one chlorine molecule, and then also now the two electrons separate, which are going to go into the positive electrode and complete the circuit. And then you've got on the second one down, on the next one, you've got the copper, the charged copper ion combining with two electrons from the negative electrode to produce a regular copper solid. So that's the two half equations for copper chloride. The hydrogen and the OH- ion will just recombine and back as water. So they'll just stay as water. So